Let's find the xy coordinates of the point of intersection for these lines. So we have a dot here. Visually, we can simply count 1 to the right and 2 up. So the x value is 1 and the y value is 2. So graphically, if you are able to draw two lines, it's very easy to find, or at least to estimate, where the lines hit. Consider the lines. Our first line, L1, is 3x minus 2y equals 4. So this is our first line, 3x minus 2y equals 4. Our line 2 is y equals 4. Where do these two lines, L1, L2, intersect? We're just going to use substitution. We're going to substitute y equals 4 into here. So 3x minus 2 times y equals 4. Using basic algebra, 3x minus 8 equals 4. So 3x equals 4 plus 8, which is 12. And so we have x equals 4. We know the x value, we know the y value, so the coordinates of the point of intersection is 4, 4. We can verify this by sketching this graph. We isolate for y by throwing negative 2y to the right. We have 2y is equals to 3x minus 4. We throw the 4 to the left. We divide both sides by 2. We have y is equals to 3 over 2x minus 2. And so when we draw this line, visually, y equals, the y-intercept here is minus 2, 1, 2. And the slope is rise over run, 3 over 2, 1, 2, 3, and then 1, 2. So this is quite a steep graph, approximately looking like that. And when we say y equals 4, 1, 2, 3, 4, something like this, we can estimate that the coordinates of the point of intersection is going to be around here, which looks feasible. It looks plausible that x equals 4. Now this is not so exact, but using algebra, we believe this is true. X is 4. Now let's continue to use algebra using this technique called elimination. We have 4x minus 3y equals 5 represents the first line. And here's our second line. We're going to copy this underneath the first equation here. This is equation number 2. Let's move it over here. We have 3x plus 4y equals 10. Notice how the goal is to eliminate one of the variables. It doesn't really matter if we eliminate x or y. Once we figure out one variable, we can simply substitute or eliminate again to find the other. Let's get rid of the x's. We're going to multiply equation number 1 by 3, and we're going to multiply equation number 2 by 4. Essentially, we're finding the LCM of 4 and 3, the coefficients of x. So what we have here is 4x times 3 becomes 12x. Minus 3y times 3 is 9y equals 5 times 3 is 15. And multiplying equation number 2 by 4, we also get 12x plus 16y equals 10 times 4 is 40. And now let's subtract. In math, we are allowed to subtract entire equations, top minus bottom or bottom minus top. Let me just go bottom minus top. 12x, take away 12x, disappears. 16y, take away negative 9y. Two negatives become a positive. 16 plus 9 is 25y equals 40 minus 15, which is 25. So we can see that y is 1. And once we have y is 1, we can plug into any equation to figure out what the x value is. Let's just plug it into this equation here. So we have 4x minus 3y, which we just figured out is 1 here, equals 5. 4x minus 3 thrown over becomes 5 plus 3, which is 8. Divide both sides by 4, we have x equals 2. So we have the coordinates of the point of intersection as 2, 1. For the sake of practice, why don't we try using substitution? let's take this equation here and isolate for y. 4y equals minus 3x plus 10. We're moving the 3x to the right, so it becomes negative 3x. And then we'll divide both sides by 4. Y is equals to minus 3x plus 10, all divided by 4. So we know what y is. Y is, in terms of x, negative 3x plus 10 divided by 4. And from equation 2, we're going to take this y and substitute it back into the other equation over here. So we know the y value goes here. So from equation number 1, 4x minus 3y, and y happens to be this value here, minus 3x plus 10, all divided by 4, equals 5. So this is looking a little bit messy, but we can just continue to concentrate and get the correct answer. I don't like this denominator here, so why don't we multiply each part by 4? So when we multiply each part by 4, the denominator, let's see what happens. We have 16x, and what we have here is a denominator 4, so essentially we can make the denominator go away. So we have minus 3, we keep the brackets, and the 4 disappears, equals 5 times 4, which is 20. Now we use distribution, 16x plus 9x minus 30 equals 20. So we have 25x. When we throw the negative 30 over, it becomes plus 30. 20 plus 30 is 50. So we have x equals 2. So we worked pretty hard to get the same answer, that the point of intersection, the coordinates of the x value, is x equals 2. And once we have x equals 2, we can again substitute into any equation to figure out y. This here seemed like a bit more algebra. I think it might be a bit easier to use elimination than substitution.